Hello, everyone. Welcome to the last lecture of Computer System Security CST750. This week, we are going to talk about cloud and IoT security. It depends on the speed. It might be one or two videos. If we go fast, I finish it in one video, or we may have two videos. Let's see. Okay, we will be talking about cloud computing, and we define we see the definition of cloud computing and cloud services based on the NIST definition. We talk about components and concepts and services that we might receive in a cloud system. And we also talk about, after getting the introduction and preliminary discussion about cloud, we get into the vulnerability and security challenges of cloud systems and also the security patches or approaches that people take in order to make cloud secure. After that, we talk about Internet of Things. What is the Internet of Things? Basically, all of our devices now have the capability of getting connected to Internet, and that makes something that we call the Internet of Things. And again, there are some features about IoT systems and IoT devices. What are those features and how those features imply some security properties or challenges or shortcoming to our IoT devices and IoT systems. That will be the next discussion in this course, and we review the security vulnerabilities for IoT and security patches. So let's get started with the definition of cloud systems and cloud services based on the National Institute of Standards. I'll be talking about it in the next slide, and we review the definition and we check every single detail of that. So first of all, what we see here, we see that the uh, kind of the range of services are very broad.
Almost covers everything from network to server to storage. For example, if you have ever used, let's say, Microsoft Drive or Google Drive or Dropbox, these are all cloud systems that they offer storage. You can store your information, your files in those type of clouds. But also we have application clouds that they give you some applications as services. For example, Office 365 is an application cloud at which you go and you run, for example, Microsoft Word without having Microsoft Word installed on your computer. So the first thing I want to kind of point to with this kind of definition, with the first paragraph of this definition, is the services, the type of services that we may see in a cloud system or in cloud systems in general is very broad. It's not only about hardware and network and CPU time. It also covers application, storage, and any other type of services that we can imagine. We later see that even security solutions can be offered on a specific cloud, on a security cloud we'll be talking about. Okay, it's about the shared pool of resources that are network accessible, which means that I shouldn't have I shouldn't stay in the same location with the cloud systems or cloud computers. I should be able to reach the cloud resources wherever, regardless of my location, regardless of my place. And it is on demand, means that whenever I like, I should be able to receive the services. It should be convenient. And another kind of property that we see here, we later see that these kind of technical terms in this definition, they are basically all required properties for cloud. And yeah, I was telling that the other property that we here see is a minimal management effort. We don't want to kind of make it complicated for the user. Okay, so it's about a cloud system is a system that offers some types of services and it is shared and it is easy to use. Okay, the next sentence of this definition says the cloud model promotes availability and is composed of 5 essential characteristics. So we have 5 characteristics which are basically somehow mentioned in the first sentence of this definition. And in the next slide, I'm gonna kind of dive into them. So 5 essential characteristics, that's the first thing that we need to know. and then three service models. We have also three service models for cloud, and then four deployment models. Okay, now let's get started and kind of look into the details. We said that there are five characteristics for cloud systems. What are those five characteristics? We said that there are three service models. What are those three service models? So we're gonna look at all of these kind of items mentioned in the definition of NISC. Okay, here are the kind of list of characteristics, and as you see, uh, these are the characteristics: broad network access, rapid elasticity, measured services, on-demand self-service, and resource pooling. Okay, let's get started by defining the first one: broad network access. Uh, per NIST definition, cloud services should be broadly accessible through network. It means that first of all, I should be able to access the services wherever, regardless of my position, regardless of the place I am, and I should be receiving the same level of services. It shouldn't be like that, okay, since you are on campus, for example, you receive services A and B, and while you are off campus, you receive only service A. No, this is not the case for cloud. All services should be accessible through network, regardless of the place, first. And second, it should be broadly accessible, meaning that you shouldn't be limiting, or a cloud provider shouldn't be limiting the users or customer to to kind of some specific type of devices. For example, if you are a cloud provider and you are offering a service like storage cloud, that storage service should be available on my mobile phone, on my tablet, on my computer, on my laptop, and everywhere, regardless of the device that I'm using that service. So this is a definition of broad network accessibility that we see NISC ask for any cloud kind of environment. The second thing is rapid elasticity, which means the ability to expand and reduce resources according to given a specific service requirements. Of course, we may have different users with different requirements. We are, for example, we are a we are a storage cloud provider, and we offer storage services. But of course, not all of our customers have the same requirement. Maybe one, uh, they come and they only need 1 gigabyte of storage. The other one comes and they need, let's say, 100 gigabyte of storage. So the requirement might be different. It should be easy mm, for the system to reduce and expand the services based on the requirement. Measured services. Again, this is something kind of obvious because we are talking about cloud, and services are going to be offered to the customer. And of course, there should be some uh, billing. I'm offering you this service, and of course, I'm going to charge you for something. So for having that happen, we have to have some type of measurement. We need to we need to be able to measure the amount of services uh, that the provider is offering to us, because the billing or the payment should be somehow proportional to the services, the amount of services we have received. So it says the ability to automatically control and optimize resource use by leveraging the metering capability. So the metering capability is will be used for billing and kind of financial, and also it will be used to control and optimize the resources as well, because the metering gives the cloud provider idea, for example, how to manage, how to control the resources it has. Okay, the next characteristic based on NISC kind of definition is on-demand self-service. It says a cloud service consumer or customer, that we call it CSC, should be able to automatically manage his or her services as needed based on his needs or her needs, without a human interaction with the service provider. Which means that, for example, I'm using a Microsoft Office 365 as an application cloud. and I should be able to add and remove some features, or I should be able to drop some of the applications if I don't want and add some if I want. This is called self-service on demand. You receive the services that you need, and you can, without kind of complicating the situation, you can easily add or remove the services that you are receiving. Resource pooling, which is kind of obvious, of course, in a cloud system, we said that it's going to be a pool of shared resources, and that's a characteristic for cloud, and that should be seen in any cloud system. And when we say a pool of or a set of shared resources, when we say resources, it might be physical resources even. For example, the CPU time. We'll be talking in a kind of few minutes about different service models that a cloud may offer. And you'll see that when we say services, those services might be physical services, CPU time, or amount of memory that you as a cloud user or customer you are receiving, the amount of memory. So the resources might be physical resources or might be virtual resources, like for example the amount of processes that you are allowed to run on it, or the application that you are running on the cloud. Okay, now let's talk about the service models that we may see in a cloud computing or cloud system. We have three general models of services in a cloud. The first one is called service software as a service, which basically says the cloud is giving us or is offering some software or some applications as service. Uh, and then we have platform as a service. A platform will be offered as a service to the cloud users, and the users or consumer of that service will have the opportunity to run their own application on that platform. And then lastly, we have infrastructure as a service, which means that an infrastructure is going to be offered as a service, and the uh, user would have the option mm, to install his or her own operating system, and on top of that run his or her own application, so that it's kind of more flexible. So here are the details. Software as a service. What is a software as a service? SaaS provides services or service to customers in the form of software, and especially application software running on the cloud and accessible through internet or through a network or remote. It enables the customer to use cloud provider's application running on the provider's cloud infrastructure. For example, I mentioned Google Gmail or Microsoft Office 365. The basic property or basic feature of application of SaaS is that you as a cloud customer or cloud consumer, sometimes they call it cloud customer, sometimes they call it cloud consumer. It's both names are okay. We as a cloud customer, we have the option to run or to receive services of a specific given application or software, like for example, Microsoft Office, without having to install that application in our local computer. So you don't basically have the Microsoft Office installed on your computer. But you can, of course, receive that services through a web browser interface. So the application are accessible from various clients devices through a simple interface, and that interface is most of time is a web browser. So you use a web browser to run Microsoft Office on your computer while you don't have Microsoft Office installed on your computer. You even may use a totally different operating system. For example, you may log in, you may start using Microsoft Office 365 while you are on Linux, and those kind of services will be available to you. You can almost receive all functionality, for example, of Microsoft Office without having it installed on your computer. So this is a application cloud or software as a service. So Of course, it's going to be very easy and convenient for our user, and we don't have to install, like I said, that specific application in our desktop or in our local computer. We don't have to deal with the license issues. We don't have to deal with the, for example, software update and let's say software patching and stuff like that. Especially if you're talking about an enterprise situation or an organization, let's say with 1,000 different computers that they have, for example, Microsoft Office installed, upgrading, software installation, maintenance, and patching is going to be a big problem, because you're not talking about one or two computers. You're talking about the, let's say, campus wide. ANT, for example, may have more than 1,000 workstation, and for each of them, you want to have Microsoft Office installed and working. So it's gonna be a burden for the ITS. Assume that we may have different computers with different specification and even sometimes with different operating system. So the upgrade installation itself is a big problem. And then it comes to maintenance, upgrade, patching. All of them is going to be time consuming and problem for the ITS. And if everything migrate to cloud, ITS is going to be is going to have a very easy time, because uh, this is now the cloud provider's responsibility to install that application, to maintain that, to upgrade it, or to patch it. And it's going to be very easy because they run it on multiple or few computers, which are basically the cloud servers. And everybody in our campus or in our in the organization will be connecting to that application using a simple interface that we said is most of time a web browser interface. And then you can run Google Gmail or whatever you have in Google, Google Document, Google Slides, or Google Spreadsheet. And Microsoft Office is another example. And there are many examples of software as service. The next option is platform as a service, at which the cloud provider kind of provides to customer a platform on which the customer application can run. So here is a point: customer's application. There is no application installed or developed by the cloud system, and this is the customer or consumer responsibility to develop or deploy their own application. So uh, PaaS, platform as a service, enables the customer to deploy onto the cloud infrastructure or create their own application onto the cloud infrastructure. Of course, PaaS clouds, they provide useful software building blocks. So there are some building blocks if you want to really create your own application. There should be some kind of uh, tools available. How you are going to develop that application. There should be some, for example, programming languages available. So some software building blocks are there that you can get them connected and create bigger applications. Or if you want to create something from scratch, programming languages, runtime environment, they are most of time available in PaaS, so that the cloud customer or cloud consumer can go and use them in order to develop and create their own application. And there are also other tools that assist deploying new application. So uh, here, basically in the PaaS, there might be some application that pre-developed by the cloud provider that we may or may not use them, but we here basically have the opportunity, have the option to create and develop our own application or deploy an application that we like. We haven't developed that. For example, you go to Microsoft, let's say something, and they have Word in the Office package, and they don't have something like let's say PowerPoint, and you deploy it. You buy it from somewhere and deploy it on the cloud server, or you create that application, you develop that application from scratch and you deploy it on the cloud. Yeah, here is a kind of good sentence that I liked it. I put it here. It says PaaS can be seen as an operating system in a cloud. Basically, the service that you are receiving is an operating system. In a PaaS, the customer receives an operating system service. So, and mm, basically, you can run whatever you like. You can install basically. We can also see it this way. You can install whatever you like on onto this operating system which is provided to you. Yeah, PaaS is good, specifically when we are talking about organizations. You have 1,000 employees or kind of um, uh, subscribers, and of course that organization may have some kind of preferences. They may want to tailor down some of the applications. Some applications, their employee or their kind of subscriber, they use a lot, so they want to put it on cloud. Uh, so that gives the PaaS gives organization like this a kind of a good level of flexibility, and they can develop whatever they want. They can remove whatever they don't want, which is good for both kind of from both financial and maintenance aspect. And here are some examples of PaaS: Apple Engine, App Engine, sorry, Engine Yard, Heroku, Microsoft Azure, Force.com, Apache Stratus, and these are all kind of platform as service examples of platform as service clouds. Okay, and lastly, we are going to talk about the third and the last service model that we can see in cloud system. It is called infrastructure as a cloud as a service, or IaaS. In IaaS, the customer has access to the resources of the underlying cloud infrastructure. So it is not the operating system that we can install or develop our application. It is even lower level than that, and we can manage the resources. And those resources covers, for example, processing, storage, network, and other fundamental uh, computing resources. The customer can configure them. The customer or the cloud user has the option to manage, to control the even kind of, like I said, more low level resources like storage, network bandwidth, number of processors. These can be all uh, controlled by the user, and of course the user, the customer, will use them, will configure them with respect to their needs, with respect to what type with respect to the type of application or type of operating system that they are going to run, they are going to kind of launch on that cloud infrastructure. You may wonder, here kind of is a trick that uh, here we are saying that the low level resources like hardware level resources like network bandwidth, storage, memory, number of processors, these are also kind of those parameters or those items that the cloud customer can configure or has some levels of control on them. If that's the case, you may wonder how the cloud is working, how the cloud system is getting connected to the user remotely. Because basically, for having the cloud operational and work, there should be some operating systems installed. But in IaaS, we say that the operating system can be configured based on the customer's needs, based on the customer's preferences. So how is this possible? The key here is, of course, we say that in the IaaS, operating system components and the hardware components are configurable, and the user has some level of control on that. But it doesn't mean that the cloud customer is directly working with the hardware. There's a terminology here called bare metal. it doesn't mean that the user is working with the bare metal cloud system. It doesn't mean that the user is exactly or without any uh, inter in, interface is dealing with the hardware components. For example, managing the amount of memory, because that way sharing doesn't mean, or the cloud, how the cloud is supposed to work, because there is no operating system. The way it works is through virtual machines. The cloud system, when it comes to IaaS, the cloud system runs some virtual machines and gives full control or full configurability uh, within or inside each of the virtual machines to the cloud customer. So the cloud customer kind of imagine that he or she, they have the maximum control over the operating system controls or operating system components, sorry, and also the hardware components. Yes, that's true, but that's limited to their own virtual machine. So if we have, for example, let's say three users or three customer in our IaaS cloud, it means that our cloud has a bare metal, which is basically all resources with no operating system. We install an operating system. Let's say we install operating system uh, Windows on it, and we generate three virtual machines. Each virtual machine goes and will be allocated to one of the customers, and the customer try to configure whatever they like. It that includes their operating system, the amount of hardware for different components, memory, processor, blah blah. But everything is limited to their own virtual machine. So this way, first of all, we give them the give them a high level of controllability over the hardware plus the operating system. And secondly, we separate the users from each other, because if we have three customers for a cloud, for an IaaS cloud, the customer shouldn't kind of interfere. For example, I'm customer number one. I'm reducing the memory. You are customer number two, and you like to increase the amount of memory. So what would happen at the end of the day? Is it really decreasing or increasing? So, like I said, I'll be increasing in my virtual machine, and you will be decreasing the memory in your own virtual machine. And that's the key point of IaaS. And here are some examples of infrastructure as service: Amazon Elastic Compute Cloud, Microsoft Windows Azure, Google Compute Engine, and many others. Okay, I like this slide because it kind of compares the layers, the stack of uh, kind of mm, stack of services that we might see in a traditional computing environment, for example, in a traditional on premises system, which basically means that you own your own computer and you have them set up in your organization or in your office or in your home, and you are responsible for everything and you manage everything, including kind of from the lower level like networking and then a storage. If you have servers, you do visualization if you want, and then you have operating system, middleware, runtime, data, and applications. Everything is going to be managed by the user. When it comes to IaaS, some of the layers of this stack of system will be kind of managed and will be controlled by the cloud. And that includes networking, storage, server, and virtualization. You, as a user, you will have the option to configure the operating system and everything on top of that. But lower than that, you don't have option. And this is, uh, like I said, below this layer is kind of the bare metal, the actual hardware. In platform as a service, even the operating system, middleware, and runtime configurations are not going to be under the control of the cloud customer. The cloud customer can only configure the data or change the data and applications properties. As software as a service, even the applications are not under the control of the cloud customer, and everything is going to be managed, everything is going to be controlled by the cloud provider and the cloud system. Okay. Uh, The last thing, if you remember, the NIST definition points to three things: five characteristics, three service model, and four deployment models. The deployment models is very easy, so I just put them here, and we have a table that compares them. Uh, we our cloud system, a cloud system may be developed as a public cloud, or a community cloud, or private cloud, and hybrid cloud. Public cloud is kind of, and private cloud are the two extremes, and the other two kind of lays in between. And here is the comparison in terms of cost. Of course, the public cloud is the cheapest one because it's gonna be used by many users, and it's gonna be shared. The costs are gonna be shared between more number of peoples. And then private cloud is going to be the kind of most expensive one because you want to run a cloud system only for your own organization, for let's say 100 or 1,000 users, not more. Community cloud is, of course, offering services to a community of users, and it's going to be less costly. And then which we say that the cost is medium. And then hybrid cloud again is medium, which basically means that a part of your cloud is public, another part is private, or some services are public, some services are private. And in terms of security, of course, the public cloud has the lowest security. That's why we say that moderately secure. And the private cloud offers the most secure option because again everything is under control uh, of the organization, and everything is only allowable to some specific users. And hybrid and community clouds, they offer very secure, so they're not as secure as a private, but they're of course better than a public cloud. So in terms of scalability, here is the range. We have limited scalability for private, limited for community, high scalability for public, and very high for hybrid. In terms of performance, uh, private and community are good because the number of users are not that high. Public is very low, and the hybrid is good. And in terms of reliability, public is low because you are having many users. Community and private are very high, and hybrid cloud are medium to high. Okay, now I guess we have enough background about the cloud systems. Now let's talk about the security issues that we may face in cloud computing, cloud systems. Of course, security is a major uh, kind of issue and consideration for cloud system, and the main reason is that uh, we are replacing on-premises systems with the cloud services. We used to have our own computers and our own applications developed, and everything used to be under our own control. But now it is not the case, and most of that layers in the food stack of the system, from hardware to the application, most of them, or at least half of it, is going to be outsourced to some other organization or some other company. So of course, the security is going to be a major, at least consideration if it's not an issue. Availability is also a major concern because mm, at least psychologically, it's more kind of, it gives you a better feeling once you have your own computer. Let's say you have your own laptop with you, and wherever you go, you have access to Microsoft Office. But if you want to use Microsoft Office on cloud, uh, that's something that you don't have it with you all the time. So it's kind of gives the impression that the availability might be an issue, at least for some cases, for some situations. And another thing to kind of consider here is we shouldn't only thinking about um, big companies, tech companies like Microsoft, Google, that their cloud systems and cloud servers are up all the time, and they offer the services 24/7. There are smaller communities, smaller, sorry, clouds that availability might be a big issue for them. Auditability of the data is also another issue which is which should be addressed. We need to collect the data and audit the data in order to make sure that everything is working perfectly. So these are all high level considerations that once we migrate from on-premise computing to cloud computing, we should be addressing them. Okay, when it comes to cloud, businesses should perform kind of do diligence on security threats both from outside and inside the cloud. Okay, what does this mean? It means that the cloud users are responsible for application level security. You are a user of a cloud system and you are using it. Anything related to application level security, you are responsible, you should be taken care of. And cloud vendors or cloud service provider are responsible for physical security and some software security as well. And security for intermediate layers of the software stack should be addressed in a collaborative way, which means that both users and vendors should be kind of working on it. Cloud providers must guard against the theft or denial of service attack by their users, and users need to be protected from kind of each other because, mm, of course, we know that cloud is a shared resources, and there might be many users at a time. So, denial of service, information theft, and stuff like this should be taken care of. Okay, business should consider the extent to which the subscribers are protected against the provider, uh, especially in the area of inadvertent data loss, which means that if you are a business or an organization and you are using some type of cloud services, you should be making sure that you and your subscriber are aware of the amount of or the levels of protection offered by that cloud service to you. Okay, now let's talk about some threats and vulnerabilities for cloud systems and kind of address or point to high level countermeasures for them. The first uh, security threat that we are going to talk about is abuse or bad use of cloud computing. And what it is, it says basically in a cloud systems, uh, from my market standpoint, the cloud providers, they very like to make the registration and initial kind of steps needed to join to a cloud. They tend to keep that very easy because you should keep it easy so that you can expect a higher number of kind of subscriber or users come to you. But this ease of registration enables attacker to get inside the cloud and conduct various type of attacks, such as spamming, malicious code injection attack, and denial of service. So here there is a kind of trade-off between the ease of registration and start receiving services from cloud and the security. The countermeasures might be these: a stricter initial registration and validation processes, which of course, again, is a trade-off between the market and the security, enhanced credit and fraud monitoring and uh, coordination, comprehensive inspection of customer network traffic, because if you look at the network traffic of the customer, you may know if they are normal or abnormal users, monitoring public blacklist for one's own network blocks. These are high-level countermeasures that can somehow address the bad users or abuse of cloud services or cloud systems. Okay, the second threat or vulnerability for cloud computing is called insecure interfaces and APIs. What is the interface? We've talked about interface. We said that basically there should be an interface that the user or cloud customer somehow get connected to the cloud and receives the services the cloud is supposed to offer. Uh, we say basically there is a set of software interfaces or APIs which are used by the customer to interact with the cloud. These are very important from security standpoint because these are the gateway that connect the customer and cloud. And if these interfaces are available or they working, the cloud is working. If they are compromised, if someone can kind of breach into them, it means that the cloud is down and the cloud is not working anymore. So the security and availability of the interfaces and APIs is very important. And the countermeasures include analyzing the security model for uh, cloud service provider interface, so analyze their security model, work on their security, ensuring that a strong authentication and access control are implemented. Authentication and access control is very good and is kind of can help for many security issues. So it says use authentication. So only only those authentic and authorized users can access to the interfaces and APIs, and no one else can kind of get connected to them. Okay, the next vulnerability is malicious insider, which says while using cloud, an organization relinquishes direct control over many aspects of the security because many of those layers are now being developed, are now being implemented on the cloud, and this organization is not controlling them. So the direct control will be handed over to the cloud provider. So now uh, that means that in some cases, some of the users of that organization, some of the insider may use this opportunity, may use this situation as an opportunity to develop some sort of attack because the organization has no longer longer control uh, uh, some layers of that software stack, and the malicious user or malicious insider user, when we say insider means that we're talking about someone inside that organization, can use that to develop some types of attack. So uh, so here are the high level countermeasures: enforce strict supply chain management and conduct a comprehensive supplier assessment, specify human resources requirement as a part of legal contract, which means that if we, for example, you want to hire someone in A&T and we have some services receiving from cloud, we put that in the hiring contract and say that okay, you are going to join this institution, join this organization. You should make sure that you are not using this service, this cloud service for such and such malicious activities. Require transparency into overall information, security and management practices, which means that make it more clear the security and management practices as well as compliance reporting. Determine security breaches notification processes. Make or put specific security notification processes that notifies people and administrator about security breaches. Okay, the next vulnerability for cloud systems is called shared technology issues. This kind of vulnerability applies only on IaaS that at which we kind of offers the cloud customer the highest level of access. They have access to the virtualized operating system and they can control the hardware components or they can manage the amount of memory, CPU time, and stuff like that. And this is in terms of security, the only layer between the cloud user and the actual hardware is a virtualization layer. And here we only have one layer of protection. So in terms of security, our security is very fragile. We only have one layer, and if that layer is broken, it means that our system is going to be compromised and the attacker can access to the hardware resources of the cloud system, which is very bad. So the countermeasures include implement security best practices for installation and configuration. So we should make sure that the installation and configuration processes are secured, are controlled. Monitor environment for unauthorized changes or activities, which means that you basically let the user to change and configure the hardware components, but at the same time you're monitoring his or her activity to see what they are doing. Promote a strong authentication and access control. Like I said, access control and authentication always help. Enforce service level agreements for patching and vulnerability remediation, and conduct vulnerability scanning and configuration audits, which again means that you collect information about the IaaS to see where are the potential vulnerabilities and how they should be addressed. Data loss or leakage, this is clear, of course, when we say data, when we migrate from a local computer to a cloud system, of course, the user data might be subject to loss or might be subject to leakage. This is, of course, something about the user. We are here talking about the user data. User data might be lost, user data might be leaked. And what are the countermeasures? Implement a strong API access control, encrypt and protect integrity of the data, uh, and while transmitting the data from the cloud to the client computer and at rest, analyze data protection at both design and runtime, and implement strong key generation and key management uh, kind of algorithms. Basically, encryption here might be used, and you can encrypt the data even using asymmetric encryption algorithms, so that while the data of a user is placed and stored in cloud storages, the data is protected, the data is encrypted. And if you want to use asymmetric, you probably need key generation, key distribution algorithms that basically you should be doing. Account or service hijacking. Uh, a user account might be hijacked in order to kind of take advantage of cloud systems, or in order to implement other types of attacks on the cloud system. Or the service of a cloud system might be hijacked without kind of even breaching into account of a user, which are both kind of bad. Both of them kind of attack the cloud system, and the countermeasures are prohibiting the sharing of account credentials between users. So you are a user, you are not allowed to share your credentials with anyone else. Leverage strong two-factor authentication techniques. Again, like I said, authentication is always helpful. You can use two-factor authentication to make sure that account of the user is not going to be compromised. Employ proactive monitoring to detect unauthorized activities for the service hijacking, and understand a CPS class service provider security policies and service level agreements. Make the users understand these policies and agreements so that they don't want to use their account to attack the cloud system. Okay, and the very last uh, type of uh, vulnerabilities we may see in a cloud system is called under unknown risk profile, which basically means on the cloud, the client passes the control to the cloud provider, and a number of new risks and vulnerabilities may appear because, for example, you are using, let's say, uh, Microsoft Drive, and you are relying on Microsoft Drive. You may assume that, okay, my data is encrypted there, but that's not the case. So these misunderstandings bring, this is of course an example I'm giving, not the whole story, but this type of misunderstanding puts you in at some risks which are new to you. You were not under such risk when you were storing your data on your local computer, but now you're at risk of some new vulnerability. And so the client must pay attention and clearly define the roles and responsibilities. Uh, and this way, um, the risks can be minimized. At least we realize that, okay, my data is not protected. If it's not encrypted. If I want to encrypt it, I should be doing it on my own. Or I should add the cloud provider to encrypt my data or to add it to the services that I'm receiving. The countermeasures are this: disclosure of applicable log and data, a partial or full disclosure of infrastructure details, and monitoring and alerting the necessary information. Okay, we are done about the cloud and high level uh, security issues and the countermeasures for cloud computing and cloud systems. Now I'm going to talk about a very interesting type of cloud, which is called security cloud. Before getting into that, I think we can finish this lecture within one video. Probably we don't need to. I don't need to record two videos. It's gonna be from now. I guess we only need another 20 minutes. So I'm gonna continue and record this video. So it might be slightly a little bit longer than our normal 50-55 minutes, but it's gonna be only one video for this week. So I think this might be a better option. So let's go this way. I could cover most of them. So that's it. We would have only one recording this week, and there is no attendance code. I mentioned. Uh, so let's talk about the cloud security. What cloud security as a service says? It says, hey, you are offering everything as a service on cloud platforms. You have storage cloud, you have processing cloud, we even have fully hardware clouds. For example, Amazon has some FPGA clouds, which are basically chips that you can run something on them. You have network clouds. Why not security? Security is also a problem that people have some solutions for that. Why not offering that security solutions as a service to the people? And this is what cloud security as a service is all about. Uh, it says that basically uh, it is first of all called SecAAS, security as a service, is a segment of software as a service, which is being offered to the customers. And it offers security solutions to two types of kind of users or peoples. First of all, it offers a security solution to cloud-based infrastructure and software. What does this mean? It means that you are a user and you are receiving a cloud service, like for example, a cloud storage service from provider A. You're not 100% sure or you're not 100% satisfied by the security level they are offering. So you go to cloud service provider B and you buy security solution from them, from cloud system B, and you patch or you connect these two kind of services. You receive from now on, you receive storage services from B, which is kind of indirectly come from uh, system A. So basically, what it happens at the end of the day, you are boosting the security properties of the storage service that you were receiving from cloud provider A. But that happens through a separate cloud provider, which only offers security solutions. So this is one kind of approach that we can use it. And the second approach is, while we use security as a service to boost the security of our local or on-premise systems. So there is no cloud services for us. We just want to make sure that our local computers are secure. So we go online and uses uh, security as a service. We buy it from a cloud provider, and now everything is going to be protected. And these are the list of services that might be found in a SIG AAS: identity and access management, data loss prevention, web security, email security, security assessment, and almost everything is going to be, whatever we know as a security problem and security solution, you basically will find it on SIG AAS, which is very interesting. idea. Okay, we are done about the cloud and cloud architecture and mm, cloud security issues. Now I'm going to talk about the second kind of portion of this lecture, which is Internet of Things or IoT. Again, I first introduced the architecture and features of IoT, and then we quickly look into the security challenges of IoT. Uh, okay, you probably have heard the IoT or the Internet of Things term. Let's first see what does it stand for and how this term is kind of was coined. It refers to expanding interconnection of a smart devices to tiny devices and sensors. What this statement says, it says that basically we used to have uh, what we used to have internet access or wireless access only on our kind of, let's say, fancy devices, like for example laptops or tablets. It was like this maybe, for example, 10 years ago. But now internet access is kind of expanded, and even a small or tiny devices, and later I'll say that even sensors are now capable of getting connected to, um, are somehow featuring some wireless connection, and that wireless connection helps them to get connected to internet. Let me give you some example. Your refrigerator now these days, it's a very common thing that you can connect your refrigerator to your local home internet, and you can control the refrigerator while you're not home. So how is that possible? Of course, you have some wireless connection capabilities embedded into your refrigerator. Of course, that's not a normal computer. It is a computer, but that's a very tiny in terms of computing resources and capabilities. It's a very tiny computer. It's a very small device. It's an embedded system. Basically, we call it an embedded system. Or even, for example, your some features in your car, or for example, your home's temperature can be controlled. Your home's thermostat or your home's AC uh, these days can be controlled over internet using the wireless connections. So all of those means that we are expanding the wireless connection or internet access from smart devices to tiny devices and even sometimes sensors. I'll be talking about the sensors later. Okay, and like I said, it comes from a trend or a dominant theme that we are embedding short-range mobile transceiver into wide array of gadget and everything items, which means that we add wireless connectivity to almost everything. That includes our appliance, our personal devices, and this enables a new form of communication between people and things. You can communicate, you can interact with your refrigerator, you can interact with your thermostat or home AC, home heater, your door garage can be opened or closed remotely, and everything like that. So we are interacting with many devices or many things. That's why we called it Internet of Things. It's no longer about only about humans on the internet. It's also including human and other objects, refrigerator, TV. Uh, so that's why we call it Internet of Things. Okay, the way it works is that these tiny devices or these objects deliver sensor information, uh, collects information through some sensors. Of course, you have a refrigerator. In order to interact with the refrigerator, what's the goal? The basic goal is for you to know the current temperature inside the refrigerator. Is it good enough or not? Or the amount of items you have, or the number of items you have inside your refrigerator. So there should be some sensors. These tiny devices, they use some sensors and they collect information from the sensor. Sometimes they do small processing or weak processing on them, and then uh, they may send it to the cloud for further processing, or they may not. And sometimes they, based on the interaction between the device and the human, the device may do some interaction on the board, or they may impact the board. For example, you see that the temperature of your home is not good enough, you increase the temperature if it's in the winter, for example. So that's the interaction between you and the device, or you and the thing, and that thing is now going to impact the environment, which is called also actuation. So here is the story. The basic thing about the IoT to know is that the IoT devices, or these tiny devices, the reason we call them tiny is that they are basically embedded systems or embedded devices. When we say embedded device or embedded system, it means that there are small computers. When we say a small, that small refers to almost everything. In terms of size, they should be small. You don't want to have the computer of your refrigerator or the control of your refrigerator as big as a laptop. That doesn't make sense to you. It should be a small board somewhere in the refrigerator. So in terms of size, they're small. In terms of weight, they should have a low weight. In terms of bandwidth, they have a very limited bandwidth. In terms of processing power, they don't have a super kind of strong processors. Sometimes they even use microcontrollers, which are 8-bit processors and very weak processors. In terms of memory, they have a very limited amount of memory. So, uh, so they're weak, tiny devices. We may think about some few examples, like examples that we wanna stream, high resolution cameras. Yeah, of course, we have these things as well. And these are examples of IoT devices. Yes, that's true. They need high bandwidth. They probably need high processing power because they're working with video. But these are kind of a few fraction of the IoT devices. And in general, we see IoT devices as tiny devices with everything is limited and low. Okay, here is a kind of figure that says you have sensor, and the microcontroller receives the data, processes the data. It has a transceiver to receive and send data over wireless, and then RFID tag to be authenticated, and actuation, which means that it impacts the environment. Okay, what is edge? We also have another terminology called edge or edge processing. In many cases, we have a network of IoT devices, network of IoT components, which are kind of connected to some network, and that network might not be exactly the same as internet networks. They may communicate with other uh, uh, kind of dedicated network. For example, in home securities, if you know, there is a network called Zigwave that you can have your devices connected through that network, and that's different than normal Wi-Fi network. So the network of IoT devices uh, uh, is a network that might be a little bit different than our normal network, uh, but that network has some level of capabilities. So it collects the data first of all, and has the capability uh, to some extent process that data or pre-process that data. Of course, that IoT network later through some gateways is going to be connected to uh, normal computer. So if I'm an organization, if I'm an enterprise, I have two networks, a traditional kind of network of computers and a network of IoT devices. This network of IoT devices is the front line to the data. So because the sensors are in the IoT devices. So you collect the data through the IoT devices and their own network. You can process it to some extent there. So that's why we call it edge computing, because you are processing the data at the edge of your network. Your network consists of IoT at the edge, and then at the back end, you have the traditional network. So this is all about the edge and edge computing. The set of IoT devices, they can form a network that which is called IoT network, and that network is going to be later connected to the traditional network or our normal network, and we see that network at the edge of our network. And if we have the capability to somehow process the data to some extent at those IoT devices, we say that we are processing the data at edge. Of course, the IoT devices or edge network, they can collect the data, they can aggregate the data, and of course, they'll be sending it to higher level entities for further process. And the gateway, which is somehow the interface or the devices that interconnect the IoT enabled devices to higher level networks, they can also uh, do the aggregation or pre-processing as well. Okay, when it comes to IoT security, it is different than normal computers and normal systems security, um, and it's not easy to find vulnerabilities. It's not easy to address vulnerabilities, even if you find them. And that brings, and also there are even, they might be even vulnerable to some new uh, uh, kind of exploits as well. So why? Here are the kind of the reason, and here are the differences that we see in IoT systems and basically in embedded systems, even more general than IoT, in all embedded systems. The main thing comes from the hardware manufacturing and production uh, side. And what it is that the chip manufacturer and device manufacturer, what they care most about is cost. They want to keep their cheap or ICs. When I say cheap, I mean this type of cheap ICs. They want to keep it as cheap as, and this cheap is about the price. They want to keep it. They want to keep the cost of ICs as low as possible. So they want to produce chips which are very cheap. So it means that they don't have any kind of strong motivations into add security solutions. And if you want to really add some security solutions into your ICs, it's gonna complicate everything, and it's gonna increase the cost. The same thing for the device manufacturer. Those kind of manufacturer that they pick up some chips, put them together, and develop a board, and that board or that device is supposed to do something for you. For example, the electronic part of the refrigerator, that's a device which is being manufactured by the company. Also, they are not too or that much interested about the security solutions and security. So this means that basically from the design time, there is no security concerns kind of considered. So the devices and the chips might be vulnerable, and the devices produced are very broad. So even if you find something, it is not easy to patch it. For example, you find a vulnerability in your refrigerator's controller, uh, which is a which has the capability to get connected to internet. So how you wanna patch it? It's not like a normal computer that you get connected to internet and update your operating system. Even updating operating system or firmware is gonna be a burden in those devices. So this results in hundreds of millions of internet connected devices which are vulnerable. And certainly we have also the same problem with the sensors, because sensors are uh, kind of the processing now even can go further and get closer to sensors. So the sensors also can be compromised, and it allows the attackers to attack them and falsify or collect the false data. The same thing about actuators. Actuators are the devices that impact the environment. They also should be considered. Their security should be considered, but basically, it is not, because again, manufacturers, they mostly care about the keeping them as cheap as possible. Okay, all of these things together kind of made the International Telecommunication Union to release a recommendation for the security requirements of IoT systems and IoT devices. You know, ITU, they release recommendation, and which means that it's not mandatory, it's a recommendation. And in this recommendation, Y2066, they released the required security requirements for IoT. Yeah, these requirements are defined as being the functional requirements during capturing, storing, and transferring or aggregating and processing the data of things. And these requirements include communication security. The communication between IoT devices and higher level networks should be secure. Data management security, service provision security. If the IoT device is offering some service, that service should be secure. That service, uh, at least, it's the availability of that service is important for us. Because if you rely on something, for example, we maybe 10 years ago we didn't have any option to look inside our refrigerator while not home. But these days we have that option. Uh, how did we used to do it 10 years ago? We used to open the refrigerator every time and see what's inside, what I need to go and kind of buy from the grocery. But if you rely on that, you may go somewhere and you say, okay, I can check it online. And if you don't have it, it may be it's pleasant situation, or in some cases it might be the outcome even might be more severe. Okay, integration of security policies and techniques. Now there is no way to integrate security policies of higher level uh, networks or institution organization level policies into IoT devices. The refrigerator controller or whatever IoT, I'm just saying that as an example, they don't look into them. They don't follow the security policies of high level institutions or high level or network, sorry, but there should be mechanisms to do that. And mutual authentication and authorization should happen eventually. And security audit, of course, is something that should happen, and that enables the IoT devices to be able to detect the security vulnerabilities and security breaches. Okay, thank you all. I think that's it. I'm just done with the IoT as well. And I want to take this opportunity and thank you, all of you, for registering for this course, for taking for, the course CST750. Please prepare for the exam, and I would love to, to see your great answers and great responses to the exam questions. The detail about the exam is already announced on Blackboard. Also, I would like to ask you, please go and participate in the final course survey. That's a big thing for me. That makes a big impact on my career. Please go and provide me with your feedback. Uh, your your grades, your score that you are giving me is going to be uh, helping me anyway. Uh, and please feel free to email me your feeling about the course. If you have any recommendation, if you have any suggestion, please feel free. And you know that any email you send me, including the any type of feedback, positive or negative, you don't like some part of the course, you think that something should be added, or you like some part of the course, or you like the whole course, whatever, anything is will receive a bonus point once you email it to me. And again, I'm going to thank you all and wish you the best for the rest of your career. And I hope that this course will open some opportunity for you while you go on market and you are searching for a job. And I'm almost sure that it will. Thank you and have a good rest of the day. Bye bye.